In this video, I will talk about the addition rule. The objectives will be how to determine whether two events are mutually exclusive and how to use the addition rule to find the probability of two events. Mutually exclusive is when two events, A and B, cannot occur at the same time. A and B have no outcomes in common. So if you look at this sample space, the first sample space, A and B do not intersect. So these are mutually exclusive. And the second one, they do intersect, so they're not mutually exclusive. In this example, we're going to determine whether or not the events are mutually exclusive. You roll a 3 on a die, and the event B is you roll a 4 on the die. Well, this is mutually exclusive because they cannot occur at the same time. You cannot get a 3 and a 4 at the same time. So these would be mutually exclusive. The next one is randomly selecting a male student and randomly selecting a nursing major. So these would not be mutually exclusive because they can occur at the same time. You can get a male student that's majoring in nursing. The next one is you randomly select a blood donor with type O blood and you randomly select a female blood donor. So these are not mutually exclusive because your donor can be female with type O blood. The addition rule for the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So you have to subtract off the intersection if they're not mutually exclusive. If they are mutually exclusive, the rule can be simplified to the probability of A plus the probability of B. So let's look at this first example. You select a card from a standard deck. You're going to find the probability that the card is a 4 or an ace. So you cannot pick an ace and a 4 at the same time. Those are mutually exclusive. So the probability that you get a 4 or an ace will be the probability that you get a 4 plus the probability that you get an ace. You don't have to subtract off an intersection because these do not occur at the same time. So it would be 4 fours in the deck of cards out of 52 and 4 aces out of 52. So it would be 8 out of 52 or 0.154. The next example is you roll a die, find the probability of rolling a number less than 3 or rolling an odd number. These are not mutually exclusive because the first part is you roll a number less than 3. So less than 3 would be 1 and 2. Or you roll an odd number. If you roll an odd number on a die, you can get 1, 3, and 5. So as you can see, 1 is common in both of those events. So you would use the rule, the probability of A, I'll write it up here, the probability of A plus the probability of B minus the probability of A and B. So this is the rule that you use because they're not mutually exclusive. So the probability that you get a number less than 3, remember that would be just 2 and 1, so that's 2 out of 6. The probability that you get an odd number would be 1, 3, or 5, so that's 3 out of 6. But then you have to subtract off the probability that is less than 3 and odd. Well, less than 3 and odd would be the number 1, and that's 1 out of 6, so you would have to subtract that off. So you'll have 4 out of 6, which is 0.667. In this example, the frequency distribution shows volumes of sales in dollars and the number of months in which a sales representative reached each sales level during the past 3 years. Using this sales pattern, find the probability that the sales representative will sell between 75,000 and 124,999 next month. Well, if you look at this example, these are mutually exclusive. They cannot occur at the same time. So as you can see, let's see, if you add up the months, it's 36 months. So you have 7 out of 36 plus the 9 out of 36. You add the numerator, you get 16 out of 36, which is 0.444. In this next example, a blood bank catalogs the types of blood, including whether it's Rh positive or Rh negative, given by donors during the last 5 days. The number of donors who gave each blood type is shown in this table. We're going to find the probability that the donor was type O or type A. Well, you cannot be type O and type A at the same time, so these are considered mutually exclusive. So we know we have a total of 409 donors. There are 184 who are type O and 164 who are type A. So we add those together, put them over 409, divide it out, we get 0.851. The next example says find the probability that the donor has type B or is Rh negative. Well, you can be B negative. That's what Rh negative means. So you can be a B and you can be negative. So these are not mutually exclusive because they can occur at the same time. The probability that you are type B is 45 out of 409. The probability that you're negative is 65 out of 409. But then you got to subtract off the intersection, and the intersection occurs right here. So you will have to subtract off 8 out of 409. You get 102 divided by 409 and you get 0.249. So here's a summary of probabilities that we've gone on from the previous sections. Everything is in this table if you wish to refer to it. Refer to it. That's the end of this lecture.